Alright, so it's been about a month and a half of radio silence from me, and I kind of apologize for that. Kind of don't, because, I mean, I had shit to do. But I can understand if you guys are getting if you want to hear a bit more of my knowledges on stuff. Um, Anyways, enough joking around. I've been working on this scene for the past few days, and there are some pretty interesting elements of this that I thought might be interesting uh, to put in a video, and I'm going to cover them. I think I'm going to focus on two main things. That is, how did I make this terrain, which is, by the way, it's all 3D, and this lighting effect, um, the sort of scattering that you get from the lights. But yeah, let's get into it. So I'm going to start with the terrain. So I want to show you, this is the project file. Let's get rid of this ugly ass cube for the fog here. You can see this is all 3D. It's not just a background texture that it composites stuff in. It's actually got pretty much everything baked into the terrain height itself, and then the texture just provides additional detail on top of that. So the question presents itself, how did I do this? And you might think I used some sort of world, like terrain creation software, like World Creator or World Machine. Now I'd be flattered if you thought I was good enough to do this, but no, I don't think anybody's good enough to get this detail in one of those programs. But basically, I'm using real data from the Mars Reconnaissance Orbiter to create these terrains. Now, how do I do that? That's the fun thing. That's the first thing I'm going to show you. So, there's a site, University of Arizona, has the high-rise camera on the Mars Reconnaissance Orbiter. I think that's right. Yeah. Anyways, you can go to like their about page and all that stuff. But they have, you can go to this is the URL, but they have these things called depth terrain maps, and they have like 900 of them, well, 834, close enough. And all of these are really interesting. So let's find one. Not all of these are great in terms of detail. There are errors. It's Mars, so you can't really be sure what you're getting all the time. But a lot of these are pretty workable. Now, I am going to, let's see, this is the one I believe this is the one I'm using in this. You can see the similarities there. But yeah, this is a shaded altimetry. Yeah, image of it. You can download this, but I don't really see why you'd have any use for it. But anyways, so you'll see that there are these images right here, and you might be tempted to go to like this. Is the this first one here is a height map. You might be tempted to use this, but this is not good. Do not use this. It won't give you good results. It's not high resolution enough, and it's only 8 bits, so you'll get a bunch of stepping errors. So you're going to have to use one of these. This first one, This first one right here is the depth terrain map, and if you download it, you'll see it's a .img file, and that unfortunately cannot be opened in your ordinary photo editor. Like, you can try to open it in like GIMP or Photoshop and it won't work. That's because it's not traditional photo format. So how do you work with this? And that's where you get to the importer that you can use. So, and there's this how to use section right here. I just went up a step. I'm going to open this in a new tab. You can read all this if you want. But on one of these links, you can find the add-on. I'm not sure if this is it. No. Here. Come on. I'm sorry, this is already turning. Actually, wait, no. It's pre-built into the thing. I believe they say it right here. So, anyways, get a copy of Blender 2.79 running on your computer. It's not that hard to do. They have links to older Blender versions. Go to File, where is it? User Preferences, and Add-ons, and then just type in high rise and enable that. If it doesn't, just tell me in the comments. I'll re-upload the video. Can't be pushing out false information, right? So then you go into File, Import high-rise terrain data. So I'm going to go to my Downloads folder, and just choose the one that you just downloaded. And you can choose the terrain model resolution right here. Now, I believe for this one I had it up to like 75%, but it takes a while to import, so import it at like 10% first and then decide if you need more details. So then click up here once you have it selected and let it run. Alright, now on to the coloring. So go back to where, go back to the one that you were using, and you'll see this this red A1 underscore ortho, whatever that is. That's the red channel. So you're only given one color channel for the full terrain. There's an IRB channel, which is the like infrared, that sort of thing, which is 3 channels, but it's not for the full terrain, so I don't use that. And it's pretty easy to recolorize these things, especially because they give you a shaded relief, although it's generally not necessary. And by the way, our thing's been imported. Thanks. We're gonna come back to this later. I'm just gonna File, Import. I'm gonna import this again at a higher resolution. Let's go 40%. Might take a little while. Anyways, so download this third image. This first one that says red AEO1, whatever that is. And let's, I'm going to go back to my downloads folder here. So I already have that one somewhere in here. Yeah. Actually, wait. Hold on. Let me just re-download it. Gotta go through the processes. Can't take shortcuts when you're doing tutorials, eh? Gotta have good production quality. Rather ironic coming from me. Alright. Generally, these things download pretty fast, but just give it a second. So these are in this .jp2 file. This is JPEG 2000. It's like the JPEG's younger sibling. Can't assume it's gender, hey? But it's never used and nothing opens it. Well, actually, that's not true. A lot of things open it. If you try to open it in a just your standard like photo viewer, it might not work. So we gotta take it into GIMP. Actually, Blender does support this, but you see, I have these untitled things because I'm too lazy to name it, and they're far less space hogging than these, and they open up like 7 times faster in Blender. So as opposed to like 3 minutes to load a texture, it's like 15 seconds. So I'm going to load it into GIMP. GIMP, I believe 2.10 and higher can do this. So I'm going to grab the file we just downloaded. Why is it saying 0 bytes? Oh, that's why. Oh, and I'm in the wrong folder. Oh shit, I just opened it. Ah, that was the right one though. I guess it's an older version. I just re-downloaded it today, but yeah, you're gonna have to give it a while to open, and now this is taking forever. So, yeah, it's fun. So I might as well show you around. These are like so. These are some previews, and by the way, there's this site, aerobrowser.com. You can find and search for certain terrains that you want to check out, and you can find them again because they're named the same thing in the high-res data set. Now I believe we can actually find the exact same one in here if we look for a second. Yeah, you might have to scroll down a little bit. Yep. So these naturally do not have the highest quality because they're not using the full res. You can change the quality here a bit. There you go. Make it full screen for the full experience. You don't need grid. You don't need artificial objects. This will help you see what you're getting. That way you can see if, like, for instance, if the color data has crazy amounts of shadow built into it. This one doesn't. It's relatively color neutral, and you can see some there, but it's not that bad. But yeah, this is really neat, and you can find a lot of really cool data in here. Like the slope monitoring, this one's pretty neat. And you can see, like, this is all this is just pulled straight from Mars, and it's really interesting because you can explore these in 3D. And you can see this is the IRB channels right here, and they sometimes have them for terrains, they sometimes don't, and usually when they do not cover the entire terrain. Again, super neat, but like not very usable, which is why some of these are harder than others to recolorize. This one might be a little bit harder because there's just simply so much variation in the types of materials that you can see. Like you can see lighter sand and then darker sand there, and then there's like light band, dark sand. I mean, that's pretty much Mars. Lighter sand and darker sand, and then a couple rocks scattered here and there. But it's rather easy to judge, even if you haven't had experience recolorizing these things yet, what to do. Oh, or like what you can do to make it, which ones will look better, which ones won't. Also, if the lighting is rather neutral, it'll be a lot easier to recolorize them. Just word of warning. Still importing. Still opening. Actually, no, never mind. This isn't. I am stupid. Just trying to stall here while I completely fail. But yeah, just aerobrowser.com has some really neat stuff in it. Let's see. This one's pretty neat. I like the formations here. This is just going to turn into a 10-minute long escapade of Sam. Sam just salivating over Mars terrains, because that's what we do here on this channel. That is definitely what we do, and it's quite rewarding. Yeah, you can see, you can clearly see the errors here, right? Some of, like, yeah, as I said, some of these aren't that great in terms of accuracy. Specifically, these sort of channel ones generally aren't that good. There were a few good channel ones. I don't remember where they were. I downloaded one like a year ago that was really neat. By the way, I have this one also on my computer. I've been making maps of this one. This one's also a bit hard to recolorize, because if you look up like Mars terrain images, you'll see how the terrain color actually is. It's not just red. There's desaturated bits all over the place, like this, right? I'm not sure what's going on there. Somebody screwed with something. But yeah, it's pretty neat. SketchUp has some stuff there. Alright, GIMP is loaded. Now I want you to fully fully appreciate the scale of this terrain image. It is like, what does it say, 40K. Look, individual rocks on the cliffs. It is absolutely amazing. But yeah, and this one in particular, like on some of the terrain maps, the height maps, they have a bunch of like banding and stuff, because how these height maps are computed, they're using stereo pairs, meaning there's two images that are taken basically sort of like right after each other from slightly different positions, and using the parallax to compute the height info. And it generally works pretty good, but on, I'd say, maybe 30% of these, there's a decent bit of banding, and you'll even see some on some of the better ones, but it's generally not super apparent, especially if you keep the angle low. But yeah, let's see if this has imported, and it has. Yeah, like if you look closer, you can kind of see a little bit of it, I think. Actually, at this resolution, not really. I have one I was using on the terrain in the image was a little bit less, or a little bit more detailed. But yeah, you can actually, you can see it right there. But it's not really perceptible. So file, so save this And then we are going to open this in 2.9. Actually, more accurately, we're going to append this into a 2.9 file. I already have a higher res version of this saved. This only has 11,000 tries. I think mine is like 30 or 11 million. I think mine is like 30 or something. But yeah. So open up Blender 2.9 and then find the file you saved it as, and we are going to append this into it. So I believe it is this one. Object, it'll naturally create this as terrain. So append this, give it a second to work. And by the way, what we want to do is we want to file export as, choose a name for it, and set the file type to JPEG or PNG. I'd recommend JPEG. These things have enough detail and enough natural variation that you don't really need the extra sort of quality step you get by using PNG. But do as you must. I choose to save my hard drive storage space. Export this however you will. Just change this to JPEG. Or just leave it as untitled, which is, as we know, the proper way to address this. But yeah, I'm not going to do it because exporting this will take forever. Alrighty, so we can see the scale is actually a bit off, and the Arrow browser and just HiRise in general gives you, I believe, actually, never mind, this doesn't give you, it gives you the scale per pixel, but Arrow browser gives you the precise scale. You can see it right there. And this naturally imports at like factor 5 or 10 times bigger than it is, so just S.1 and set this to the center. Alrighty, so alright, the other blend file I've opened for the scene with the rover is taking up a ton of memory, so that's fun. It'll be slow for this tutorial, and we're kind of gonna have to deal with it. So this terrain data looks absolutely astonishing in rendered view, even without textures. Let's go into cycles, not Eevee. Alrighty. So give it a second to update the BVH. Let's actually, well, let's see, forget exactly. Yeah, there are like 25 million triangles. Yeah, so give it a second to update the BVH. Alrighty, boom. I'm going to change my view distances. Alrighty. So we can see this is an exceptional clean piece of terrain. There's actually very little banding in here, especially, and you can easily see that in the rendered view. I mean, there's some, and you can see it, but it's not super apparent, especially, and it'll be less apparent once you have a texture on it. But yeah, these things are awesome. Absolutely awesome. I love messing around with these. Okay, enough salivating over terrain. Let's actually add the texture. And the nice thing about this is if you import it, or if you appended it correctly by using the Object tab instead of the Import or Append Mesh, actually, I'm not sure. I never use Import or Append Mesh. Maybe you will. But you get the UVs are automatically assigned here, so that the high-rise cameras, which always do weird stuff with the orientation of the image, right? Like you could see in GIMP that wasn't like fully, it didn't take up the entire space of the screen, right? It was a little bit rotated and stuff. This will naturally correct that, so add in a material. Now I'd recommend for the start to kill the principled and just directly preview the image, because this has some lighting data baked into it already. So open up the folder, or not folder, the image that you exported in GIMP, or from GIMP to the JPEG, and let's go into rendered view. Now it's going to take a little bit of time, but you will see how it looks. Alright, updating images now. Shouldn't take too long, considering we just made it an empty JPEG instead of .jp2. Awesome. Alright, let's open this up. So we can see how realistic this terrain is from many different levels of view. And I'm going to close this because I don't want this open. And it is stupidly slow. Alrighty. So you can see, actually, I mean, I bet you this looks familiar. This is the camera angle I chose to use when in the other image, right? And you can see this is where the river was. There are the hills. All this stuff looks so amazing from up close. It's just incredible. Obviously, there's a limit, right? But at low camera angles, you can kind of skirt by. But yeah, this is quite impressive. Unfortunately, you need a pretty good GPU. I think that goes without saying, with a decent amount of VRAM, because these are 40K textures. But yeah, pretty nifty stuff. Anyways, you might want to relight these. Some of these work better than others with relighting. This one happens to work pretty well. So, and a principled VSDF. Give it a second. Give it a second. There we go. Turn specular down. Roughness up. And voila. Also, might be more contrasty when the world shader is set to black. And you can see, since you might want to shade smooth on the terrain data, by the way, instead of shading flat. But you'll be able to get up pretty close to the terrain and still have it look convincing, even under different lighting conditions. Like, look at that. It's pretty neat. As I said, shading smooth is pretty good. It'll prevent that sort of blockiness. But hell yeah, man. I love this sort of stuff. I think it looks awesome. Okay, so that's enough with the terrain. I believe I promised I would show you how to do those lighting sort of things, these sort of volumetric lights. And this will be more classically node-based, which I think people here generally appreciate. So, start out by making a cone. I think Blender has a, yeah it does, no, we're going to use some cylinder though, because cone, I forever disown it. And also this will just naturally help out, because we don't want the base to be a point, we want it to be like an actual face. So scale it down till it looks like a cone. Period 6 to set the origin to the 3D cursor, and scale this up a decent bit. Actually, you know what, let's just keep it like that. We can scale it up if we need to. Oh, and we want to point this down. So RX180. There we go. Alright. Shading tab. Cycles, GPU compute. Let's go into rendered view. So we have a material, and we want it to be a volumetric emission based material. So stick an emission into the volume shader, and boom, we're done. No, this looks terrible. I'm just kidding with you. So what we need to do is we need to grab the X, Y, and Z position data relative to the object's orientation transformations. So we take this object output, feed it into a separate XYZ, and this will separate X, Y, and Z components. Z is black because this is below 0. So math absolute, and that's what we're going to be using here. You can see that that gives us the aspects we need. So we're going to do a combine XYZ, feed the X and Y into this because we want to create sort of a conical structure here. Or not conical, what am I saying? Cylindrical structure here with the coordinates being independent of the Z axis, and we're going to do vector math length to get the length of the vector that is outputted from here. And what we can see is if we plug this into the strength of the emission, what happens is that we get this middle area is completely black, and if we use a color ramp to invert it, we can sort of see how we can control the radius here. So now what we need to do is we need to make this conical. So how we do that is to take a cylindrical object and turn it conical is the same way that we would basically transform two parallel lines into a similar sort of thing. So if we open up Desmos and say, let's say absolute value of x equals 1. Alrighty. So this is sort of just a 2D representation. Imagine if this was revolved around the z-axis, or in this case the y-axis. So we need to transform this. We're just going to pay attention to the top half here. We need to transform this into a cone, or just a triangle. So we can divide this by the absolute value of y, and boom, and then we can basically add in this arbitrary variable a, steepen or flatten it. It's pretty neat. So we're going to use this principle. This is the y value here, the z value, and the graph that we would just use. So what we need to do is we need to duplicate this math node and change it to divide, and boom. Theoretically should work. Of course it isn't. There we go. Oh, I'm silly. Okay, so since this isn't perfect 90-degree angle, we need to add in the scalar that we just put in Desmos, the a value. So we're going to need to add in a multiply, and this will be sort of the this slope. Actually, divide might be easier. This will be the sort of slope for it, right? And we can see this tapers off around the edges. Now what I like to do, since this is incredibly linear and we can kind of see how flat it is, or like flat the slope is, flat the derivative, or whatever, flat the gradient is, change it to ease, and that'll make it a little bit more spotlighty, and then we can change this to be like the inner radius, that sort of thing. And the fun thing is, if we add a small bit to it, we can change sort of the starting radius. I like to keep this at like 0.01. I think that's like the size of the light. But we are still missing something, or we're missing a few things. But the most important thing we're missing is that light tapers off after a time. And it starts out a lot brighter than it ends. And it sort of diffuses out, right? So we're going to divide this by this and add in a power node. To basically hammer that in. And then just we're going to use this multiply to control the length that we're going to fall off. So we're actually just set this to divide. That way it's a bit more intuitive. Yeah. This will be multiply. This will control the general strength. And if we have the strength high enough, and by the way, I'm going to set this down to like 3 something, but we still see, actually let's keep this at 2, we still see it still intersecting, and the way we do that is we just take z value here, divide it by 2, right, because we want to renormalize it. Actually, you know what, I'll do something easier. Duplicate this separate RGB and just XYZ. This generated, this Z value will automatically renormalize it, and then we just multiply the entire thing by this. That way it is, and by the way, we might want to ease color ramp on there. That way it will always ease into 0 at the bottom, and we can see that we now have no intersections no matter how crazy we go. But do be warned, it might look unnatural if you go too whack with this. Right, that's a pretty quick taper off. So maybe 10 to 20 would be good. Also good to note, literally scaling this up will increase the intensity due to the property of how this works. How emission works, I mean. So I would maybe do that instead of using this. Although do use this if you need to, if you have like some super small object, if you're not using real world scales or something. Yeah. Alrighty. Next thing we need to do is we need to add a little bit of variation in the air. And how we're going to do that is we're going to use a geometry node. And this gives us the raw position of our model that's independent of object transformation. And that's really nice because we can create basically a sort of universal map of the noise in the noise in the air density, right? And that'll mean that we don't have to duplicate the material for each object, or even just use a random thing, and we can update the noise automatically with the transformations. So texture, noise texture. Now to give it some turbulence, just duplicate it, color into vector. Pretty neat. And then change the scale of the first one if you want to change the scale of the noise. So since the value of a noise texture generally averages to be around 0.5, multiply it by like 1.5 or something to get some values above 1, and then use a power node to increase the contrast, and then multiply the result using this multiply node, multiply the result of these nodes by that noise, and you will see sort of the whirliness. Now if you want to keep a base air pressure, you can use an add node and add a certain value to it, right? I like to keep this around maybe 0.25, that way you can see both of the things. And you can, when we rotate this and move it around, we can see the power of the geometry node, right? Super neat. Now if you have colored light sources, you can color this however you need. And you will have to create instances of this material. Actually, just Blender doesn't have instancing, material instancing, so you'll just have to duplicate the material. By the way, bug the Blender devs about that, because Unreal has the material instancing and it's super nice. Blender needs it. It would save us a whole lot of annoyance. So let's say we have a light source, like so we have a light and an area light, right? What we can do is we can take this and use the constraints to copy the transformations of the target light, right? And that means move this, rotate this however we want, and it ends up looking pretty neat. Anyways, that's a cool little trick. And you can see how it works well in some certain situations. This is literally like a node for node copy of what I did there. And obviously there's some more of these. I think there's like 8 of those on the rover. One for each light. And there's also a little rover over there, which has another one of those. And yeah, there's some pretty neat stuff there. I think I might explain how I did this. I think it's relatively obvious. Just take a cloud VDB or anything that looks noisy and stick it behind the rover and mess with the density. And that's basically it. I like to duplicate it a couple times, duplicate the materials, that sort of thing, and just sort of make it so that it's a little bit denser, closer to the wheels. As you can see, you get more detail there, but it kind of like diffuses out a bit. Shows motion pretty well, I think. I need to add motion blur to the tires. I know. It's kind of the main problem with this, the motion blur on the tires, but I like it. Well, lack of. But I like this sort of how it turned out. You can see some light satellite dishes, that sort of thing. And I learned a lot in composition through this, by the way. I'd like to shout out a few people anonymously, but some people on various Blender Discord servers did help me out a lot with composition, and I thank them for that. And that's why this is my new YouTube banner, which is super fun. Anyways, I want to give you a bit more info for those who care about certain series on this channel and why I've seemingly forgot about them. The answer is I have not. I have actually some shit recorded that I need to get around to publishing. Like the Atmosphere series. I have the next one, but I've been hesitant because it's super math heavy, and the first half of the video is deriving equations of light transport functions using Desmos, and then the next part, which is somehow even more confusing, is implementing them into Blender nodes. And while I think it's helpful, I think that there's going to be a lot of confused people on the Discord server in the comments section. I am not sure if I'm prepared to deal with that, and I'm not sure if I'm prepared to let other people go through that sort of confusion. But I will still upload that sometime soon. And by the way, I love it when people learn stuff, and I should articulate this better because I just did a terrible job. People often copy node setups node for node with my tutorials. Very few people are actually able to understand why I'm doing something, and that's something that with these sorts of node setups and this sort of complexity, and for somebody who's not verbally gifted, let's say, it's nearly impossible. I know some people who have done it, like done it really well, but there's an intuition that's built up over time, and people generally sort of, when they come to my tutorials, I know like some of them, the veterans, they come to my tutorials for a bit of inspiration to see how I did something, and then they just leave because they don't need to see the nitty-gritty details because they needed that one level of abstraction, but they got all the others. And I love it when people do that because they always create something super unique and different than what I come up with. But I mean, I'm not going to blame anybody for just copying node setups, but it's not the sort of thing I want you guys to do with these tutorials, because you don't really learn a whole lot other than maybe a couple things about what certain nodes do. And I mean, any learning is good learning, but you end up with a lot of very homogeneous results, right? I've seen a bunch of people do the same black hole over and over again. I don't blame them because I didn't show them how to do anything else. But it's something that part of the reason why you make tutorials in Blender is you want to see what people make with those tutorials. You want to give the spark of inspiration. There's definitely been some great results that I've seen. I don't want to undermine those. And even people who have just literally copied the node setup but just changed values, they've done some pretty creative stuff. But the issue I'm getting at is I don't exactly think that if you're forced to copy the node setup, that you're really getting the full experience of learning the strategy behind why those nodes work. You're given basically a mathematical formula. Well, you are literally given a mathematical formula to do something, because that's what nodes are. They're math. Pure math. Literally pure math. This is all math nodes. And you're using it. I'm not like saying I have any copyright on it or anything. That's ridiculous. But part of the interesting thing about these sorts of very complex math equations that are represented with nodes is that there's always something in it that can be used in some other scenario. And part of what I've failed to do, I think, is just generally teach the abstract sort of concepts of what certain groups of nodes do. break down these equations very well. Now again, I want to reiterate, you aren't doing anything wrong by copying these node setups. I don't want to imply that. I'm saying I'm probably doing something wrong, but you're also being misled that this is some sort of, I don't think that's really the whole way to learn, if you can understand that. So, yeah. I think I'm going to leave it at that. I'm not sure if I fully really articulated what I wanted you guys to get from it, but I hope that didn't come out too aggressive. I don't mean to be aggressive. Look, as I said before, anything that you guys are doing with my tutorials and spending the effort and time on them, I'm super happy about. Couldn't be happier. I'm glad that I am making some I'm glad that I'm making some genuine impacts on people's skill sets in Blender. What I just want to restate the issue here is that I'm worried that, and this is a me problem, right? I'm worried that I'm not fully connecting with the viewer about what the nodes are really doing, right? And it's generally just presented as this abstract formula which does shit. And that's not how I wanted to do it. So that's going to conclude the tutorial. Again, I hope that came across pretty well. Something I've been meaning to talk about. But yeah, that's about it, guys. Hopefully you've found something interesting through this ridiculously chaotic mess of a tutorial. And it's really been that. Usually there's some sort of structure. Today there hasn't been any. I'm kind of getting back into the game, sort of figuring out what's gonna go right. So actually I want to give you a bit of insight into what's gonna come next for the channel. Is that I've got some people that have offered to actually edit my videos and change and like increase the production quality quite a bit. Just sort of snipping out parts that don't need to be there. At right, like I say for about 10 minutes each video is just you could basically it's like those when in movies you hear the Buddhist monks going and that sort of shit. You could just compile all those times I've said and you basically have a 10-hour soundtrack of that. Say it again. But don't expect, because I'm not good with fulfilling expectations. Maybe be ready for an increase in video quality sometime soon. The video quality is, I mean, I don't have a great mic. I don't really have a great recording system. But hopefully with some tweaks it can get better, and I trust the people that I've offered to do this, and I thank them, and I'll link them in the description for each video that they edit, so you can definitely check them out. I'm not going to mention names right now in case they withdraw their agreements, or actually it's not an agreement, withdraw their offers. So to the couple people who've done that, thank you very much. Services are incredibly appreciated, and yeah. Alright, finally done. Shit, forgot to mention the Patreon. Whatever. Check the description for links to stuff. You need help? I got a Discord server. I've also got the comments. I'll try to respond to the comments. I haven't been good about that. I need to get better about that. Alright. Goodbye, guys. And I hope to be more active soon. especially because Christmas break's coming around. Hopefully you've learned something. Hopefully you make something really neat with this. I really hope to see some really interesting stuff. I hope this high-rise terrain data proves useful to you. I love it so much. Just so much detail. So much quality. But yeah, have a good one, guys. See ya.